Whenever you're solving for the missing side of a right triangle, you can use Pythagorean theorem, which is a squared plus b squared equals c squared. The most important letter is to look at the c, which is the hypotenuse across from the right angle. And then it really doesn't matter which one you put for a or b. So I know 3 squared is 9, 4 squared is 16. When I add them together, they equal 25. And the opposite of squaring is square rooting. And y'all know the square root of 25 is 5. So the hypotenuse is 5. This is what we call a special right triangle, or Pythagorean triple, because there are 3 numbers that fit in the Pythagorean theorem. 3 whole numbers that fit in the Pythagorean theorem. So 3, 4, and 5. You could multiply it. So instead of 3, I could use a double of everything. So another Pythagorean triple that's easy to remember is 6, 8, and 10. That's just doubling the sides. Another Pythagorean triple is if I were to triple the original sides. So instead of 3, 3 times 3, so 9, 12, and 15. They would all be 3 whole numbers that would work out in the Pythagorean theorem. There's actually a lot of Pythagorean triples. I gave you a few in class that I want you to memorize. Another type of right triangle that we talked about were 45, 45, 90 special right triangles. So those are also called isosceles right triangles because if 2 of your angles are congruent, then that means that those 2 sides are also congruent. So 3, 3, and x. Again, to find the missing side of a right triangle, we said a squared plus b squared equals c squared. We knew that the most important side was c, that is opposite the right angle. So I like to plug in c first, and then it doesn't matter which one's a or b. We know 3 squared is 9, 3 squared is 9, 9 plus 9 is 18, and then to simplify, or to solve for x, we take the square root, and the square root of 18 is not a nice, beautiful, perfect square, so we had to factor it. So we know the square root of 18, that's 2 times 9, or 2 times 3 times 3. And whenever you're simplifying a square root, you basically look for pairs. We know 3 times 3 is 9, so the square root of 9 is 3. So the hypotenuse, the exact answer was 3 times the square root of 2. And then we did a few more of these in class, and we realized, hey, there's got to be some faster way than doing the Pythagorean theorem a bunch of times. So the trick was, if you know one side length, like let's say 5, then obviously you know the other side length because it's an isosceles triangle, and without having to do the Pythagorean theorem, you know that the hypotenuse is going to be 5 square root of 2. So let's try another. If this is 61, then this other side is going to be 61, and the hypotenuse is going to be 61 square root of 2. It gets slightly harder when you're not working with the smallest side. So let's say they gave you the longest side, which would be the hypotenuse. Well, if I said the longest side was 50 square root of 2, it's pretty obvious that the 2 legs are going to be 50 and 50. But what if they didn't have a little square root of 2 on the hypotenuse? The way you find the legs is you just do the opposite. You divide by the square root of 2. Now, in math, for some strange reason, we don't like square roots, or what we call radicals, on the bottom. So in order to get rid of that, you just multiply by the number 1. Or in this case, whatever the bottom is, which is square root of 2, over the square root of 2. So you multiply fractions straight across, that becomes 50 square root of 2, and on the bottom we have the square root of 2 times the square root of 2, which is the square root of 4. Hopefully y'all know that the square root of 4 is beautiful. It is 2. And then we simplify our fraction. Looking at my numbers that are not underneath the square root, 50 divided by 2 is 25. And I ran out of space, so I'll just write it up here. 25 square root of 2. So that means my legs are 25 square root of 2, 25 square root of 2, and my hypotenuse is 50. So let me do another one really quick. Let's say that the hypotenuse is 20. Again, there's no little square root of 2, so to find the legs, you just divide by the square root of 2. And we don't like the little square root symbol on the bottom, so all you have to do is multiply by the square root of 2 over the square root of 2, because that's the number 1, so anything times 1 is going to be itself. So I'm not actually changing anything, I'm just changing the way it looks. And so on the top I have 20 times the square root of 2, and on the bottom I have the square root of 4, which y'all know is just 2. And then to simplify a fraction, we combine the numbers that are not in the square root. So this 20 divided by 2 is 10. And then I have the number outside the square root. So the legs are 10 times the square root of 2. And one leg, another leg, and then my hypotenuse is 20. And you can check using the Pythagorean theorem if you want. And the last thing we talked about in class was the 30, 60, 90 special right triangle. The 30-degree angle is obviously the smallest looking angle, the 60-degree angle is the medium looking angle, and the 90 angle is the right angle. So it's easiest to start off if you are given the smallest side, and the smallest side is always going to be opposite the smallest angle. So my smallest side is right over there. So let's say the smallest side was 1. The next thing to find is the longest side. So in a special right triangle, a special 30, 60, 90 right triangle, the hypotenuse is going to be twice the smallest leg. So 2 times 1 is 2. And the middle side, across the middle angle, is going to be the smallest leg times the square root of 3. So that's 1 times the square root of 3. Now I don't need to multiply by root 3 over root 3 because that square root of 3 is not in the bottom. You can check this using Pythagorean theorem if you wanted to. So let's do another one. Let's say that my smallest leg was 2. That means the largest side is going to be twice as big, so 2 times 2 is 4. And my medium size is going to be the smallest size times the square root of 2. The square root of 3. Ta-da! And you can check using the Pythagorean theorem if you wanted to. Let's do another one. If the smallest side is 5, what's the hypotenuse? 10. Good. If the smallest side is 5, what's the medium size? 5 root 3. Okay. Now let's say I gave you the hypotenuse first. Let's say I said the hypotenuse was 10. Hopefully y'all remember that meant the smallest side had to be 5. And once you find the smallest side, then you can find the medium side. Let's do another one. Okay, let's say that the hypotenuse was 20. That means the smallest side across the right angle is going to be half of that. And then the medium side is going to be 10 times the square root of 3.